Hello viewers, welcome to this video. Right, in the last video we saw how to use KubeKey to deploy a Kubernetes cluster, and as promised in this video we will see how to deploy KubeSphere on top of the Kubernetes cluster. Right, so we've been following this documentation with version 3.3. so if I go to all-in-one installation on Linux, what we did was we prepared a Linux machine, Ubuntu 18.04 using Vagrant. We gone through the requirements and then we downloaded KubeKey. We used the KubeKey create cluster command with Kubernetes version 1.24.0 and let KubeKey create a Kubernetes cluster with containerd as the container runtime, and we didn't actually have time to test this with KubeSphere option. So in this video we're going to be using the same command, but we are also going to pause with KubeSphere so that we know that we are going to install KubeSphere on top of Kubernetes and see how the KubeSphere UI is going to look like. So for this I'm going to be using the same Vagrant file that I used in my previous video. So if I do an ls, so we have a very basic Vagrant file. So if I do vi Vagrant file, so you can see it's basically a very simple Vagrant file using generic Ubuntu 18.04 Vagrant box and with a couple of blocks for the providers. So basically if you're using libvirt or VirtualBox, what you're trying to do here is set the CPUs to 2 and memory to 4 gigs. So that's what the document recommends us to have on the node. Alright, so let's bring up Vagrant up with the provider libvirt, but feel free to use VirtualBox provider if you like, but I'm on a Linux host machine, so for me libvirt works better than the VirtualBox. So doing Vagrant up, it's going to take about 30 seconds to bring up the virtual machine. And if you remember from the previous video, we have to install a couple of dependencies, socat and contract, and then we are good to go with and then we have to download the KubeKey because I've completely destroyed the virtual machine and now we are creating this machine from scratch. Okay, so the machine is ready. Let's SSH the machine, become root user, and then do a quick check to see if what we got is what we expect to have. So Ubuntu 18.04, 4 gig of memory, yeah, 2 CPU and more than enough, plenty of free space in the root file system, and apt install socat and contract. Okay, so that's done. So now we are good to download the KubeKey. So let's copy this file, copy this line here, or feel free to go to the GitHub releases page if you are worried about what this script is. It's just simply downloads the latest version or the version you specify in this environment variable. It downloads from the GitHub releases page and untar it. So that's basically what it does. So I've gone through that and I know what it's actually doing. So we are downloading the latest release, which is version 2.3.0 of KubeSphere. So let me delete the tar file and move KubeKey to user local bin. If I do which KubeKey, right, we have KubeKey with the help option, so we'll be using the create cluster command. If I do KubeKey create -- help, it's going to show me the subcommand, the help for the subcommand create. So we can create config, we can create manifest, we can create cluster, and if I do KubeKey create cluster help, so it just tells us what options we can use with the create cluster command. One thing we'll be using is the container manager to tell which container version we want KubeKey to install for us. So by default it tries to install the Docker container runtime if the Kubernetes version is 1.24 or prior to that, but anything above 1.24 you need to specify the container manager. So I'll be using containerd as the container runtime. So either you can install the container runtime of your choice manually in this virtual machine or let KubeKey do its job. Alright, so that's all looking good, and now we are good to proceed with this command here. Copy that, paste here. So basically KubeKey create cluster with Kubernetes version. I'm going to go with version 1.24.0 with KubeSphere version 3.3.1, which is the latest at the time of recording this video. But if you always want the latest version of KubeSphere, you don't have to specify the version. So with KubeSphere, without any option, is going to go ahead and pull the latest of the KubeSphere. Okay, I think that's all we need. Okay, so what we're missing here, so we are missing the container runtime, so we need to pause the container runtime manager. Let's use container D. Alright, so this time it should be okay, and it's asking for a quick confirmation, typing in yes. So it's going to download, as you saw in the previous video, it's going to download a bunch of binaries, kubeadm, kubectl, kubelet, helm, etcd, core DNS, and all those things, and then it will download, it will pull all the container images required to bring up the Kubernetes cluster, and also the container images needed for running the KubeSphere. It will then use kubeadm to initialize the Kubernetes cluster. And the difference to this, the difference to the previous video is here we are installing KubeSphere on top of Kubernetes. So it's going to take a little while because it needs to download a bunch of container images required to run KubeSphere, and also the time it takes for all the pods to be in a running state so that you can log into the web UI and things like that. So in order to log into the web UI, you need to wait until all the KubeSphere related pods are up and running. So it's going to take a little while. So bear with me. Okay, as you can see here, it's using the KS installer tool to install KubeSphere on top of Kubernetes cluster, and it says please wait for the installation to complete. So it's going to wait for all the pods, all the required pods to come up to be in the running state before we can start accessing the web UI. So at the end of this command, it's also going to show us the URL to access and also the credentials, the admin credentials to access the KubeSphere web UI. Let's wait for that. Okay, so the command completed, and it took about, you can see here, the last time it started in deploying KubeSphere was about 2:01 and 2:07. It took nearly 6 minutes, but I don't know, if we had given it more resources to this VM, it might have completed a lot quicker, but I don't know. But anyway, so here's the address. So that's the deployment. I think that's the node port, and 192.168.121.171 is the IP address of this virtual machine itself, and that's the node port. So later we will check by running this command, basically just to see what we have in the KubeSphere system namespace. Okay, so let's first try and log into the web interface. So if I copy that, go to the web browser. Okay, so the username and passwords are going to be here. So admin and password is this funny password. Okay, admin and password. So the first time you log in, it's going to ask you to change the password. Submit. Cool. Okay, so that's the welcome page. It says hello admin. All right, so what else we have in the console output? So after you log into the console, please check the monitoring status of service components in the cluster management. If any service is not ready, please wait patiently until all components are up and running. Please change the default password after login. So that's what we've done. And then maybe we could try and run this command to look at the logs. So let's try and run this. Okay, so that's the log, and it's the same as the one that we just saw, and you can see here it seems to be using Ansible kind of provisioning. So you can see the provisioning log, and at the end it shows us the console URL and the credentials we need. Alright, so kubectl get nodes. Again, we will have one node, which is the control plane, as well as the worker node. Kubectl get namespace. So we have a bunch of new namespaces for KubeSphere. So KubeSphere control system, monitoring, federated monitoring system, KubeSphere system. Let's take a look at KubeSphere system namespace and look at the pods. Okay, so we have the API server, console, controller manager, and KS installer component. All right. So kubectl get namespace. Let's see what's in the monitoring namespace. Kubectl get pods. Okay, so already I can see a problem here. So there is this Prometheus deployment and the alert manager deployment are pending. So it says it has got 2 pods. Might be one of them might be a unit container or something. It's in the pending state. All right. So that's about the, let's take a look at kubectl get pods -a, -a. Okay, so other than that, everything else seems to be running fine. So it's this one that's in the pending state, which is the monitoring system namespace, Prometheus, and also the alert manager seems to be in the pending state. Okay, Let's leave that and go back to the web console, the web UI for the KubeSphere. Alright, so if I go to the platforms, I can see there's this cluster management, unified management of multiple clusters and their basic resources. So you can use KubeSphere to manage multiple Kubernetes clusters, access control, users and roles, which you'll come to in a different video about how to create users, roles, and things like that using this unified KubeSphere interface. Platform settings, basic information, notification configurations, and all those things. Okay, so if I go to KubeSphere, so there's this one cluster which is a hyperlink, and if you click on that, but before that, let's see what's in this page. So we have one workspace, we can create multiple workspaces. So I think that's how you differentiate different clusters, I guess. And the platform version, the KubeSphere version itself is 3.3.1, which is the latest version. If you remember, we didn't specify the version with the KubeSphere. If you want a very specific version of KubeSphere for some reason, you pause it on the version to this option here. Okay, so one user, which is the admin user, we haven't dealt with creating users, roles, and things like that for KubeSphere, which I haven't explored yet. Maybe once I explore, got a good understanding of it, I will do a video of that. So let's go into this cluster at the moment. Okay, so you can see CPU, disk, memory, port, nice graphical representation. But I don't know why I'm not seeing any of the information here. Maybe there might be some. I think it's because the Prometheus and Alert Manager pods are still pending. So we need to figure out why those pods are actually pending. Because we've been following the documentation, we have given the virtual machine the same suggested recommended resources, 2 CPU and 4 gig of memory. Maybe the memory is not enough, or maybe the CPU is not enough. Let's see why it's actually failing. All right, so there we have it. Okay, so what else we have? Nodes. So we have cluster node. We just have one node here. Status is running. Role is worker. Although this is also the control plane, I don't know why it's saying it's the role is worker. And again, CPU usage, memory usage, I'm not seeing any metrics here. It might be because it's not actually doing anything, but that's highly unlikely because, so that's the Ubuntu machine. That's both the control plane and the worker node. It's just a single node cluster at the moment. So it has got loads of pods running, as you can see from here. So there must be some CPU and memory usage, but it's not being reported here. Maybe we don't have a metric server or something deployed here. So node exporter, that should work. I think it all again comes to the fact that we don't have Prometheus running, not in a healthy state. Okay, so if I click on the node, you can see you can coordinate the node, uncoordinate, edit labels, or you can add or remove taints to the associated nodes. So if you look in here, this green tick mark says that all these are good. You know, network availability is good. There is no memory pressure, no disk pressure. It's ready, no PID pressure or anything. So that's CPU usage. So you can see here the number of cores, CPU limit, memory request, memory limit set for this nodes. Memory usage, maximum pod, disk usage. Okay, so if I go to the pods tab, it says it shows us the pods running on this particular node. Metadata, monitoring, events. Okay, invalid disk capacity, kubelet, invalid capacity 0 on image file system. I think there's one warning here. And a bunch of information about the nodes. Okay, let's go back to the cluster node. Again, if I go to the nodes monitoring, I'm expecting to see something in here. Either I need to leave this node for a while so that it gathers data, or it's because my Prometheus is not running, it's not showing any monitoring data here, but we need to find out. And again, you can see here the container runtime is containerd. As I said, you see lots of information in this page. Okay, going back to the cluster nodes, what else we can see here? System components. Okay, so there's this KubeSphere, Kubernetes. Already you can see this monitoring component has got something to show us. So there's this forewarning here. So if you look at the KubeSphere, so there's this 3 deployments. API server, control manager, and console, everything is healthy. If I go to Kubernetes, scheduler, control manager, core DNS, all running fine. Look at the monitoring. Okay, so that's the monitoring thing, and you can see warning for this one, Prometheus operated. There's this warning here, alert manager, warning for Prometheus K8s, alert manager operated. I think these are being deployed through operators, and you can see here 0 of 1 replicas. Okay, let's try and see if we can find out what's going on from this web UI without going into the kubectl command. Let's pick alert or Prometheus gate for example. Okay, clicking on that one, it says it's unschedulable. Okay, if I click on that, I can see there's this init container, probes, waiting, unschedulable. If it were running, if it was running, then we will see which node it is running and what's the pod IP address and all those details, monitoring data. Obviously, if we fix the Prometheus, we can see the monitoring data. Okay, clicking on that one, what it says the image it's using and all the command, monitoring, environment variable, container log. Okay, this container does not support real-time logs. Okay, so that's fine. Let's look at another container. Okay, config reloader, container logs. Again, no container logs. Prometheus, readiness probe. Okay, healthy liveness probe, startup probe, container log, no container log. I think there's a problem with the init container. Because only when the init container completes, the other containers will get created. So there's some problem with the init container. I'm not sure what the problem is, but here you can delete view YAML, scheduling information, scheduling not successful. Why? The system schedules a pod to a node with sufficient available. Okay, current status is pending, events. Okay, so this gives me some detail about why this pod deployment is failing. 0 of 1 nodes are available, 1 insufficient CPU. Okay, so 1 no preemption begin. Okay, so we've got just 1 machine in this cluster. So this, by the way, this video is not about troubleshooting what's going on here. I'm just trying to show you the web UI, and from web UI whether you can find out or troubleshoot whether the web UI is actually helpful or it's just a web page showing details about your Kubernetes cluster, or whether you can actually interact with the cluster components and what else you can see in the web UI, things like that. So, but unfortunately, the first time we deployed the KubeSphere on top of the Kubernetes cluster, we have Prometheus and Alert Manager not running, and we ended up troubleshooting the problem, and it looks like we don't have sufficient CPU. I don't know why, but anyways, we've been recommended to go with 2 CPU and 4 gig of memory and 40 gig of space. Again, this one is an all-in-one installation in Linux. This is just for a getting started guide to get used to KubeSphere and just for playing around with the different components of KubeSphere, and that's it. I wouldn't expect anyone to use this type of setup that I've been doing in the last 2 videos in production. So this is just for your understanding. So it's okay, it's failing. Maybe the next time you could try upping the CPU to 4 cores and then maybe like increasing the memory a little bit to see if it helps. Just follow the same video. Instead of giving it 2 CPU and 4 gig of RAM to your virtual machine, just give it a bit more and see if this Prometheus and Alert Manager. That's exactly what I'm going to try next after this video. I don't want to try and do that in this video. I don't want to drag this video, but I'm going to leave that with you guys to explore why Prometheus and Alert Manager is failing, and let me know if it's just me or every one of you are getting the same result by going with 2 CPU and 4 gig of memory. And make sure you use Ubuntu 18.04 so that we are on the same page, we are on the same boat, using the same ground. Okay, all right, so what else we have here? So if I go back, we have application workloads, jobs, pods. So the list of pods, and you can already see here it's unschedulable, configuration secrets, config max, storage class. So there is this local storage class provided by OpenEBS. So that's the persistent volume claim. Storage class is local, provisioner is OpenEBS. Like I said, by default, when you deploy using KubeKey, it deploys the OpenEBS storage provisioner, so you can straight away start using persistent volume claim and persistent volumes and things like that. Monitoring cluster status, so that's again a nice graphics. So once I think we fix the Prometheus thing, then we will be able to see all the graphs here. And KubeSphere components, 3 components, monitoring 10 components, out of which 6 are okay. There's this 4, 2 Prometheus and 2 Alert Manager pods or deployments are like in the warning state. Kubernetes is okay. We haven't enabled logging, we haven't enabled Istio, so those are like kind of pluggable modules that we can use with KubeSphere. So once I explore all those external things, then I'll make a video of that. Control manager is fine, scheduler is fine, and we have 1 node and the node is online and it's healthy. Physical resource monitoring, so I think basically every monitoring bit is kind of broken. Okay, overview. That's again, we saw all those things. Cluster setting, basic information. The cluster version is 1.24.0. It says 0 nodes, 0 CPU. I don't know why. Cluster member. So at the moment, it's just one user, which is me, admin user. All right. I think that's pretty much I wanted to show you in this video. Thanks for your time watching this video. I will see you all in my next video. Until then, keep learning and keep on learning. Bye-bye.